Welcome to the Body Venture Thematic Unit Professional Development Training. This training opportunity was made possible through the collaborative efforts of the Kansas State Department of Education Career Standards and Assessment Services K-12 STEM Education Team and the Child Nutrition and Wellness Team. Today's training is centered around elementary science, nutrition, and fitness. Body Venture has gone virtual, and in today's training, you will learn how to incorporate the free lessons and kits reviewed in the training so that you can easily tailor the resources towards your elementary classroom. We hope you enjoy the training.
If your students are anything like mine were, this is an experience that has been brought to you by Child Nutrition and Wellness for years. And it's one of those pieces that students will remember all the way throughout their educational career. My husband is a high school teacher, and when I told him I was doing Body Venture and he shared that with his seniors, they're like, oh my gosh, I remember when we got to do it. So it has really been a heartbreak that due to COVID-19, we haven't been able to be in schools as much as we wanted. And so we're very excited about this collaboration to hopefully support you in your space, bringing Body Venture to life for kids. So that's what we're doing today. We're going to be doing a deep dive into the virtual Body Venture video, and then some supports that, regardless of your space, you can implement to help bring it to life and generate some of that additional excitement. I am Meg Richard. I am the KSDE STEM Program Manager, formerly the KSDE Science Consultant. We recently had some changes. So you'll notice that in today's materials, some of it will be science, some of it will represent an intercurricular nature, helping us to work towards that idea of how to best support kiddos in elementary and how we can overlap some of these standards. I also think that if we're going to spend 4 hours together, it's always nice for you to know a little bit about who I am. So I've put some pieces that may interest you just so you can get to know me on the screen, including adorable pictures of my kiddo, Edison, credentials, and then if you really want to talk about bread baking later, it's passion. And I find that, you know, when you put a picture like this on the screen doing PD, like you can't be nervous. You just put that photo on. how can it, you know, where can you go from there? It helps anytime we're going to be in a space together to come to some community agreements. So things I'll ask from you today, I ask that you stay engaged, but recognize what the school year has been. So I am completely comfortable with you doing whatever best fits your needs. If that means you're doing PD in your PJs, that is some of the best PD that we can ever do. So your pets are welcome, your children are welcome. I'm just so thankful that you're here on a Friday in November. Yeah, it's huge. So thank you. Thank you so much for being here and doing what you do to support Kansas kiddos. With that, all that being said, talked a lot about comfort. I ask that you grant yourself the grace to expect some lack of closure today and a little bit of discomfort. Nothing that we're going to do will hurt today, but it does when we think about students learning and how we want them to ask questions. And sometimes they're questions that we don't have all the answers to. Sometimes that brings a little bit of discomfort, but it's so important for kids to mirror that slight discomfort with a lack of closure. And the reason being, science doesn't have all the answers. And so when we model that with our students and we don't just say, here's everything you ever needed to know about everything that's ever been done, it really allows them the opportunity to see themselves as a scientist and to continue to investigate and discover and research and wonder. So as grown-ups, I find that I am even worse at that than I ask my kiddos to be. So I will work on it. And I'd ask the same of you. Also, speak your truth, breathe your identity. There are stupid questions. I shouldn't say that, but we all know that if we're talking about the human body and a kiddo raises their hand and asks if fluffy is a good name for a hamster, the answer is yes, but not right now. So when we come into this space, there's no judgment. So please ask questions as we go along the way. If something doesn't feel right or doesn't make sense, come off mute, drop it in the chat. Yeah, that's what we're here for. Along those lines, getting an idea of what today's going to look like, we are going to do a little bit of a dive into the standards, probably 5 to 10 minutes, no more. Stick with me. I know that standards aren't really exciting, but it is a great opportunity to encourage, if you're not a teacher, to encourage the teachers in your space to see where this fits in their curriculum. Then we'll look at how to group those together in this unit to really help kids make sense of the way their bodies work. And then we're going to dive into system by system. This is my first image. What do you think is happening in this boy's mind? The mouth is open, the eyes are big. What do you think? Have you ever experienced anything like this? Or what about this one? Oh, I love it. In the chat, I see wonder, excitement, wow. Do you think that little boy is going, oh my goodness, look at those cumulus clouds? I see amazed. I do not see in the chat anyone saying the power of condensation. I see curiosity. Okay. When students wonder, when they're amazed, when they're curious, they want to learn. So when we think about this unit, when we think about getting them started in body venture, we really want to use any opportunity we can to get that same sensation in their minds. So the very first thing we're going to do today is hopefully get your brains going on questions. What I'm going to show you is a 10-minute video produced by Childhood Nutrition and Wellness with the virtual body venture. But while you're watching this video, I really, really, really want you to keep track of what you notice, what you wonder, and what questions might arise. Now, when I talk about the questions that might arise, these may be your questions, depending on your background, or I would highly encourage you to put yourself in the mind of a student. If you teach third grade, what would a third grader kind of think as they're watching this video? What kind of things might they be curious about? Might they wonder about? And might they have questions about? And this step is probably the most important thing we do all day long. So if you don't have a piece of paper or a computer that you can take notes on, go grab that now. And without further ado, I bring you the 2021 Virtual Body Venture 21, 22, or 23, depending on when you're watching this. Here we go.
Would you like some broccoli?
Oh, no vegetables, please.
Okay.
What's the matter, Casey? You look a little tired and you're moving a little slow today. When you make choices from My Plate, it gets you ready to go, and you need all the foods to get the organs in your body to work properly. When you make My Plate choices, vegetables, fruits, whole grains, proteins, dairy, it gets your body what you need. So wouldn't you like to try the vegetables today?
All right, I'll have some vegetables.
Your brain sends messages to all parts of your body and controls everything your body does. When you eat breakfast, lunch, and supper and follow my plate, you feel great. That is why it is important that your brain has a steady source of energy all day long.
Oh, this does smell delicious. I better eat.
Welcome to the brain. Your brain is the boss of your body. It lets you feel, think, learn, and remember. Each side of your brain is in charge of different kinds of thoughts and actions. The left side of your brain is used for speech and for things you have to do in a certain order, like tying your shoelaces. The right side of your brain is for thinking in pictures. If you had to draw a map of the way you go to school, you would think about the map using the right side of your brain. You have 5 senses. They send information to your brain about the outside world. The 5 senses are touching, seeing, hearing, smelling, and tasting.
The mouth is the first step in helping get energy from food to the brain. You need healthy teeth to be able to chew mouth-watering, crispy, crunchy foods, such as fruits and vegetables, so that they can be broken down into energy for the whole body. Let's take a closer look inside the mouth.
Welcome to the mouth. We have an example here of Mr. Gross Mouth. Each of you has a mouth that looks much nicer than Mr. Gross Mouth. It's important, in order to keep our gums, teeth, and tongue healthy, that we brush and floss between every meal and snack. So I have my big toothbrush here, and in order to brush our teeth, we need to brush on the tops and in between all the grooves. It's important to get on the sides of our teeth, but it is hard to get between our teeth. So instead of using the toothbrush, we will use floss to go between our teeth. This helps get out tooth decay and bacteria between each of our teeth. Sticky, sugary foods can help contribute to tooth decay. So let's take a look at some foods and see how much sugar is in each of those foods. So here, I have what would be the amount of sugar in 10 gummy bears. That is almost the whole entire tube full of sugar. However, compared to strawberries, a half a cup of strawberries, it has very little sugar inside. And these are 2 tubes, and this is 12 ounces of soda. So if you drink a can of soda, that is that much sugar that's going into your body from that 12 ounces.
After we swallow our food, the food enters a flexible tube called the esophagus. And from there, the food is moved to the stomach by a squeezing motion. In the stomach, the smashed pieces of food mix with digestive juices so that they can be broken down even more.
The stomach is like a stretchy bag that holds the food after it is eaten. When the stomach is empty, it shrinks like a balloon without air. As you eat, your stomach gets larger and larger. If you eat too much, your stomach may stretch out like this model so that it can't return to its original size like this. With a stretched out stomach, it's easier for you to eat more food than you need.
Once the food from the stomach is mixed with digestive juices and broken down into even smaller pieces, the food moves into the small intestines, where the nutrients from our food are broken down one last time and are now available for our bodies to use. Let's take a closer look at the small intestine and what happens there.
Welcome to the small intestine. The small intestine squeezes food along like toothpaste is squeezed through a tube. The tiny pieces of food are called nutrients. Nutrients move through the walls of the intestine and travel in the bloodstream to all the parts of the body. These are called villi. We all have villi in our small intestine. The villi are not just on the top of the intestine inside of our body, but also on the sides and bottom. The villi absorb nutrients from our food. The nutrient gets between the villi and then go through the intestinal wall into the bloodstream. Villi are like doors in the walls of the intestine. The villi in your body are tiny and hair-like. If we were to stretch out your small intestine, it'd be as long as this 20-foot rope.
The villi will transport you into the bloodstream, where you will eventually travel to the heart.
Although not directly involved in helping our bodies digest food, the heart does need energy and nutrients from the food we eat. In fact, when we follow MyPlate and eat whole grains, fruits, vegetables, low-fat dairy, and lean meats and protein, then our heart is able to be healthy so that we can run, jump, play, and do our favorite activities.
Welcome to the heart.
This model shows what the heart in your body looks like. Do you know how big your own heart is? It's about the size of your fist. Each time your heart beats, the heart muscle squeezes, making the heart act like a pump. When the walls of the heart squeeze together, they pump blood, just the way you can squeeze the water out of a plastic squeeze bottle. The heart has 4 sections called chambers. The blood moves through each of these chambers.
The heart isn't the only important organ that depends on nutrients from eating healthy foods. So do the lungs, bones, muscles, and skin. From the heart, blood is pumped to the lungs. Let's see what happens inside the lungs.
Lungs take the oxygen from the air you breathe and pass it to the blood so it can go to all the parts of your body. We get new oxygen from the air each time we breathe in, and we get rid of carbon dioxide each time we breathe out. Let's see what healthy lungs should look like. When you smoke, your lungs turn dark gray from the tars and nicotine in the smoke. Smoking increases your risk of lung disease.
We build strong bones by eating healthy foods and following MyPlate recommendations. Did you know that the dairy food group on MyPlate provides calcium, vitamin D, and protein to help us build strong bones? Let's find out more.
We build strong bones by eating smart, which means eating a variety of foods that are high in calcium. Bodies have 206 bones. Our bones make up the framework called our skeleton. Our bones are long, short, round, flat, big, and little. About 100 of our bones are in our hands and our feet. Our smallest bones are in our ear, and it's smaller than a grain of rice.
Nutrients from the food we eat not only help build strong bones, but also help build strong muscles that help move our bones so that we can run, jump, play, and do our favorite activities. Let's find out more about our muscles.
Did you know that we have 636 different muscles in our body from our head to our toes? We have different size muscles in our body. We have small muscles, medium muscles, and large size muscles. This is what 1 pound of muscle tissue looks like in our body. And this is what 1 pound of fat tissue looks like in our body. Which do you think is healthier? If you said the muscle tissue, you're correct. I can see the muscles working in my body when I grab this turtle bean bag and I squeeze. I can see the muscles working in my hand and my arm. Now you give it a try. Hold your hand out and make a fist and squeeze, and you can see your muscles working in your hand and your arm.
Did you know that the skin is the largest organ in the body? For the last stop in our body, let's learn what the skin does and why it is important to take good care of our skin from the inside and the outside.
Welcome to the skin. Skin is a protective covering for the body. It covers all of the other body parts you visited today. It helps protect your muscles, your bones, your heart, and all of your body parts. Too much sun can hurt the skin. Wearing sunscreen with an SPF of at least 30 helps protect the skin. Raise your hand if you use sunscreen. It's a good idea to wear sunscreen when you're outdoors. Don't forget your face, your neck, and the tops of your ears. Use sunscreen often when you are swimming and again after you dry off. Wearing a big hat or long sleeves will also protect your skin from the sun.
We just learned that the skin helps protect our bodies from harmful germs. But another way that we can protect our bodies and keep our bodies healthy is by washing our hands. Washing our hands is just as important for keeping our bodies healthy as following MyPlate and eating a variety of foods.
I'm glad I finished my lunch. My stomach quit growling and I'm not tired anymore. Now I'm gonna go play with my friends.
hopefully you enjoyed that clip as much as I did, and hopefully you had the opportunity to jot down a couple of those questions wearing what we will call your student hat. So with those questions, not the video, but with the questions, what we really want to be able to do is help students guide their learning, help them dive in and start to direct what we do next. Now, here's the secret, because that can be kind of scary. We're not really letting them drive. It goes back to old school Madeline Hunter anticipatory set. So whenever we plan a lesson, whether it's what we did today or whatever your substitute might be doing in your space as you're here, we anticipate what kind of questions our students are going to ask, what kind of moves we're going to need to make instructionally as a teacher or as a support. And so what we're doing is we're allowing students to ask those questions in a way that gives them that ownership and then allows us to really do what we were anticipating anyway to support them in that process. Oftentimes we will hear this called a driving question board, or DQB. And to do that in our virtual environment today, we're going to use something called a Jamboard. So I'm going to drop the link into the chat. And you're welcome to go ahead and navigate there, but I want to show you how it works first, or in addition to. So I'm going to click on my link, maximize it on my screen. Jamboard is like a virtual whiteboard space. So you'll notice that along this right-hand side, all the tools that it has are a pen so you can write if you feel like it, an eraser so that you can erase, a pointer so that you can point and move things if you had an object that needed to be moved. You can add a sticky note and change the color. A picture, if you were going to go and have students find one online. We're going to use this tool a little bit later. You can draw shapes. You hold down, it'll give you different shapes. You can add a text box and change the color. Or this one is my favorite because it doesn't make a whole lot of sense. It's a laser pointer. Ready for this? I'm not quite sure of the function, but it's fun, right? Like you could use it. So what I'm going to ask you to do in your Jamboard is add a sticky note of a question or a wondering you had. Okay, so remember, I will re-drop that link back into the chat in case you missed it. And what you're going to do is you're going to add a sticky note, which is located right here, onto the board with a question or a wondering that you may have had. Originally, I had planned 8 minutes, but I'm just going to watch your Jamboard, which is also one of the cool pieces is that it populates live. So I'll be able to keep an eye on our progress. And when I start to see the post-it slow down, we'll move on. Okay, I'm going to have you pause for a second. You're going to notice that up at the top, there's these little arrows that'll take you to different pages. I see some really, really great questions for me about like how we're going to implement this. And then I see some student questions. So if you would please, I'm going to have us sort those and let's do teacher questions on the first page. And I'll add that on a text box. And then let's do, and teacher would be any facilitator, educator, person that's going to be leading the students through the experience. And then let's do student questions on the next one. If you haven't added your question yet, you still have plenty of time, but I do want to go ahead and address some of the ones on the facilitator question piece, because I would hate to have you sit through a longer period of time and not get some concrete answers on some of these. First one, and I'm hoping you can see my mouse, when we'll be able to do visits again. That is $1 million question. Hopefully sooner rather than later, but we don't have an answer on that yet. And those two questions I'm going to group together because I see a pattern between the school visits and physical tour. But hopefully when that physical tour is available, it'll be better than ever. Then, is this for elementary school students or K-12? Today we're focusing on elementary, but I think that you will notice some of the activities that could very easily be scaled to the 6-12 space. And if you have questions about that, feel free to reach out and I can definitely be a thought partner on how to do that, especially the brain. You'll see in a minute. The visual, yes, I'm going to drop in the student notebook in just a moment. And I love this. I love that whoever wrote this called our kiddo a scholar. And I love that they took the time to explain that relevant connection. How powerful is that for everyone in the building to serve as that team to really recognize our students as scholars? Okay, let's see. Yes, I would definitely have the kids ask the questions after the video. And I'll tell you why. When I watched the video, I noticed on the back of the exhibit, there were words that no kiddo is going to be familiar with, right? And so whether you just have them watch it once at the beginning and engage with the video and really make observations, or whether you watch it multiple times and give them different lenses to engage with the material, having them ask the questions is going to be an important step for how you support the video, but you'll be amazed. There's a lot in that exhibit that when you just see it once, you miss, and then you pick up all of these different pieces every single time. Now, this one, the voices being off, I'm assuming that that has to do with the fact that I'm streaming it and you're streaming it. It'll be available to you to download, so that should help with the Mickey Mouse or puppeteer situation that you may be experiencing. All right. Again, kids can be any grade. If I were grouping these together, I could put that here so that it would match up. And perfect. I love this. Yes, all body parts are intertwined. And getting kids to realize that is sometimes an adventure. And then how many days, and this is the last one I will read before we move on to the student piece, but how many days are class periods? It really depends on you. So depending on your grade level, and we'll look at that when we look at the standards, and depending on your space, some of the activities are built for physical education spaces and definitely could be done in a traditional elementary class or core content class. It really depends how much time you want to devote to it. There's no expectation for us, for you. We're just so excited that you're thinking about it and ways to still engage students in health and nutrition and wellness. Now, changing gears slightly. This activity, the driving question board, again, K-12, I encourage it with our higher ed people to utilize the driving question board as well. The benefit really being that you're leveraging student interest, you're leveraging engagement, and looking to see kind of as a formative or pre-assessment of what do these people know that I'm getting ready to teach. So the next step in a driving question board is to group the questions by the investigations I already know we're going to do. For example, what about the part of the food that doesn't absorb? This person is very polite because this question is really about looking at the chat to see if anyone's going to answer it for me. It's okay. It's really about our waste. So thinking about waste and potentially where waste comes out, I'm going to go ahead and group any question that has the word absorb or intestines with it. So this question that says, do the intestines really work like that? I'm going to match it up with this one. How do the villi absorb nutrients? Are there any others that you see that might match up with this idea of us needing to look to take a deeper dive into the intestines? Feel free to move one if you see one. I love it. So just in these questions, we have something about like the structure of the intestines. Are they really that long? And then we have questions about the function of the intestines. How do they really work? How do, like those villi that we walk through, are those like, how do those finger-like things really help me to digest and absorb my food? This one is really about lungs. This one's really about teeth. This one gets to the idea of, do we all look that way? I'm going to put the visuals because maybe if we're looking in the inside, do we all look? That's a visual. Okay. Ooh, what happens when we get sick? I wonder if this question could match up with either healthy, unhealthy, or with how does our body know what to do when? What do you think? I'm going to put these two together. And then this person's question is great. Are there other organs, or is all that we saw in the video it? Because I got my eyes. Okay. So as the teacher or the facilitator, this now gives me an idea of what my students are interested in. And I get to say to them, friends, now we get to answer some of these questions. And we're going to start where they started in the video. But before we do that, I love this idea of, as we think about the body, how we're going to stay healthy, right? Like, because that's really the driving piece. I apologize for tech. That's really the driving piece of when we think about how all these pieces work together, we want them all to work together and work correctly. So we are going to look at the standards to explain where we go next. Okay, and I know that was kind of like a quick turn, but I don't want to get too far down this road without giving you a glimpse of why and where in the standards we're doing this. Okay, so we have our student questions. Where can we match those questions up to what we are hoping to see in our classrooms? First, if you've never visited the Kansas Department of Education science website, you can find it by Googling Kansas Science Standards. You can also go to KSDE.org, but what you'll notice at KSDE.org is that you have to go to the C for Career Standards and Assessment and then navigate through there. I still, even having worked at the agency for quite a while, will Google Kansas Science Standards. Once you're at this page, you can click on the Science Standards or scroll down, and it will give you a series of pages depending on your grade band that looks something like this. In kindergarten, students, and you can see that whole page. Okay, students are to use observations of patterns of what living things need to survive. In 4th grade, we dig into the human body again with this idea that plants and animals have internal and external structures. So in plants, those structures could be thorns, stems, roots, colored petals, the beautiful fall leaves we see right now, or in science, it could be heart, stomach, lung, brain, skin. So exactly the standards we're talking about. Likewise, in 4th grade, we really want students to get this idea that signals are sent through senses. And that standard is really, really, really hard for students to visualize because we know that we get a signal, like right now I can touch the book, but figuring out how I touch is kind of challenging. This graphic, and I'm going to drop the link to this resource into the chat for you, is called Appendix E. It is the vertical progressions of all of the science standards. So you'll notice that we were looking at that kindergarten standard around external parts, and then we were looking at the 3rd through 5th grade standard of growth, survival, reproduction, and structures. So that's where I was saying, like, depending on your grade level, you can very likely make these activities fit as long as they're scaffolded in a way that doesn't steal the thunder from your other grade levels. And really the way you do that is by changing the questions you ask and framing. And we'll look at, again, a couple of ways to do that later. You'll also see that it scales all the way up to 9th through 12th grade. Thinking about in high school, really, 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 what are the functions of these organs? How do they work together? And then taking that look inside of the organs to look at composition of tissues, composition of cells, why there might be more vacuoles and lysosomes in the lungs opposed to the foot. Okay, don't need to do that in K2, but absolutely appropriate in 9-12 to take that look and different lens. Okay, you'll also see that even down here, we look at sense receptors being specialized for different kinds of information. Lots of interesting things you can do with the sense of touch on like your fingertips versus the back of your neck, etc. So this is a glimpse at the science standards. And I want to point out one more thing, just because when I first looked at a page like this, there's a lot on there, and I have in the past found it kind of intimidating. So I want to just quickly describe to you what each of these boxes is really asking us to do. Our science standards are 3-dimensional in nature. So what that means is we have our orange box, which are our disciplinary core ideas. These take us all the way back to when I was in high school, likely when most of you were in high school. These are the facts we need to know. But what we discovered very quickly is that there was this amazing invention called Google. And most of the facts that we wanted kids to memorize, they were Googling. So we had to figure out more than just memorizing facts and holding knowledge, what else we wanted them to do. And believe it or not, scientists do a lot of things. For example, they don't just do the scientific method. They analyze papers and they argue for evidence, and they examine things like muscle tissue. So the science and engineering practices are really what we're asking them to do, like ask questions, make models, etc. And then cross-cutting concepts are the lenses of which we want students to make sense of information. I wanted to highlight this because you may have already noticed that we've talked about things like structure and function and cause and effect and patterns. On our left side, all of the science and engineering practices, or those things that a scientist does, work together. And then these lenses are things that we can give our kiddos to really ask intentional questions about the content. So if I had said to you, alrighty, we're gonna watch the body venture video again, and I really want you to pay attention to scale, proportion, and quantity. So the numbers of things. I love in the video when the gentleman says, you have 4 chambers in your heart. Well, why 4? Is that a coincidence? Or is there a purpose? Is there something relevant about that structure? In the physical education, these are the PE and health standards. It aligns best with standard 3 that asks us to encourage students to achieve and maintain health enhancing level of physical activity and fitness. So right off the bat, it has students think about the foods they eat and the relationship between food, energy, and physical activity. Again, relationships, if I went back here just for a quick second, relationships could be cause and effect. It could be structure and function. So even though the wording between the science and the physical education standards are slightly different, they definitely are overlapping in the life science and the standard 3. Using my plate, poor nutrition risks, making a nutrition plan that really reflects not only the caloric needs, but hydration needs. So having that idea of what does hydration do in our body and how does it work and get absorbed? Okay. I know, I told you standards. Any questions about where we're seeing body venture kind of fit in the different grade bands or the different content areas? I'm going to add another resource into the chat, which when I email it out to you after today's session, you will be able to edit it for your own needs. What I'm dropping in is a copy of the student workbook. We're not going to walk page by page through the workbook, but just to give you a glimpse again, in case you are on a single monitor and you can't open it, the workbook looks like this. Targeted towards 4th grade because I had to pick one. But again, because you have that freedom to edit it for your space, please feel free to do so. Again, it's really the questions that you ask to support where students are. In addition to this workbook in your kits, you will each be receiving copies for each student printed out of the student activity book. Okay, so the student activity book can be used with parents and students and community members, and it's really colorful, fun activities like connect the dots, Power Panther, walking them through my plate. Each student will get a hard copy of this, but the function of this and what you see on the screen are going to be a little bit different. So the vision for the notebook on the screen is that students would be able to cut it apart, glue it into their existing science journals. You could have it on Post-its and put it up along the gymnasium wall if you wanted to, but really having them look for the pieces that mirror the instruction. Okay. So now we're going to look at what some of these activities are going to look like. And the first one mirrors together with the idea of the driving question board. And it is really starting by saying, how do we stay healthy? So what it says is, using the boxes below, go on a scavenger hunt in your home and record, write a description or add a picture of something that represents what you do to stay healthy. So at this point, we are approximately an hour in, and we're going to do this activity again to kind of help frame the connections we're going to be able to make with kids. There's a Jamboard. And this time, we're going to do it slightly differently because I'm going to put you in breakout rooms, and you're going to go to the Jamboard slide that best matches your breakout room. So for example, if I'm in breakout room 1, I'm going to go to slide 1. If I'm in breakout room 2, I'm going to go to slide 2. If I'm in breakout room 3, etc. Okay. Picture, you can write it, you can use a Post-it, your choice. The only thing that really matters is you're going to be in the breakout room that matches your slide. Okay. Those were a lot of directions, and I don't know that they were as clear as I wanted to. You're going to go to the Jamboard, add a picture, and if you can't add a picture, it's one of the reasons for breakout room. Have your counterparts add a picture for you, and I'm going to hop around and try to help as needed. But we're going to take 8 minutes to really go on a health scavenger hunt in our homes, in our spaces, in our classrooms, at Child Nutrition and Wellness, and intentionally put like things that we think help us stay healthy. Okay. Checking the chat. Yes, you will definitely be able to view the recording, but you might miss some of the breakout discussion. And someone else is really eating apples, lemons, bananas, and I'm not even sure what this is, but yes, please. What do these 3 things have in common? I see color in the chat. I see healthy foods in the chat, fresh. So really what kids are thinking when they say, when I'm sick, my mom makes chicken noodle soup, it's not that the parent is making chicken noodle soup. It's that there's some sort of vegetable, color, nutritional value, hydration. We're really wanting kids to expand what it is that they think and bring their identity, their culture into the classroom of like, I may not do yoga, but I could walk my dog. These things group together as we know that we should exercise, and that idea of maybe why. We should keep our bodies clean. We should eat food of color. So hopefully you can imagine how an activity like this, where we're group this relaxation, oh my gosh, this one makes me really happy. Also, because I'm only looking at this slide, you'll notice that the themes tend to stay the same. This one, same thing. We have toothbrushing. We have colorful fruits and veggies. We have a person in prayer or meditation or relaxation, some sort of exercise. So regardless of where we are in our journey as a class, we are all agreeing that these elements are things that keep us healthy. So now we have to think about how. 2 question boards, if you will, one about our bodies and one about health, which are going to be our 2 main objectives regardless of the content and regardless of the space. So let's first think about our brains. The dog is a dancer. What do you think? Is that body the body of the dog? No one is telling me no. But surely, thank you, Christy. Surely, like, this is not a Boston Terrier body, but our brain can play tricks on us. In the video, we heard them talk about the difference between the right brain and the left brain. So, what do you think? Do our brains have a right and left side? What could those right and left sides do? This activity for students is going to have them look at a ballerina, and I'm going to show you this video clip. For some of you, the ballerina will turn clockwise. For others, the ballerina will turn counterclockwise. So she'll be turning to the right, one she'll be turning to the left. And for some of you, you'll be able to make her switch. Okay, so be thinking about which way the ballerina turned for you. Ready? And focus really hard on trying to make her switch. You can also like turn away, reset, and then look to see if she moves the opposite direction. I can only get her to turn clockwise. My husband can make her switch halfway. So I'm curious, how many of you, yep, in the chat, how many of you see her going, yep, yeah. Okay, so the theory behind it is that it has to do with whether or not you're right brain or left brain dominant. Supposedly, you can make her turn clockwise if you're right brain dominant and counterclockwise if you're left brain dominant. And these will be in the notes. So hopefully you're not like jotting everything down. It will be provided for you in the teacher's manual. I just didn't want to give everything away while I talked. Otherwise, you wouldn't stay with me. Of course you would. But anyway, I digress. So for kids, and for sometimes us as adults, we get so excited about being either right brain or left brain people, right? Because one's going to tell us that we're logical and analytical, and one's going to say that we're creative. While there is definite science to support the idea that our brain functions differently in all of the different hemispheres, the problem with only addressing that with kiddos is that it's a very fixed mindset. We want kids to recognize that their brains are like Play-Doh or clay waiting to be shaped. If you want to impress them, throw out the word neuroplasticity and then have them say it. It's fun for us to say too. So just like in your space, neuroplasticity, neuroplasticity. It's this idea of throughout your entire lifespan, your brain is becoming more complex. Every time you have a thought, every time you see a picture, you get another little indentation where your brain is forming new connections, and we can think of our brains like a filing cabinet or like Play-Doh falling on a dirty floor, for lack of any better example, where it's just picking up everything that it touches. Okay. Now, with that, which is pretty cool, by the way, that our brains like continue to morph and shape and grow over time, kids then tend to wonder how and why. So with this activity, we're going to address the hows and the whys. With thinking about the structure of the brain and the function of the brain. Also, this is a great opportunity to not only be teaching life science, but you'll notice that we're going to address physical science as well. Thinking about matter, like what our brain is made up of is different than what our arm is made up of. So that difference between tissues. And then we're also going to be looking at energy. Because really, I had a professor explain it to me this week as our bodies are nothing more than electrical impulses inside of a meat suit. It's disgusting and amazing and wonderful. But yeah, okay. So those electric impulses, we can't see them, but we know they're there. So we want our kids to be thinking about and experiencing what those electric impulses are like. So to do that, in your kit that you will be receiving will be a series of materials to help you do squishy circuits. Now, full transparency, the Kansas Department of Education does not condone any one curricular product or material over another. But Squishy Circuits has offered all of their materials free online, which is why I feel like they deserve a shout out. On their website, you can find all of their tools for purchase or recipes to help your kids really think about the ingredients that go into this play or learning, purposeful play substance, and then you can have them create it. One will be a conductive dough that allows the electrical charges to pass through, and one will be an insulating dough. Now, in your kits, we're not providing you all of the materials to make your dough. Also, because as some of you have been messaging me throughout the session, there's a huge lack of time. And so what we're providing you is a sample of Play-Doh. And this is just a sample of everyday, ordinary polymer clay. Both of these were purchased at Walmart in the dollar bin, and I got 25, okay? So what you're gonna wanna do first, and again, if you're following along in the student guide, that's awesome. If not, that's fine too. But I want kids to experience this, even those high school kids, okay? So allow them to touch it and smell it. Don't taste it, but smell it. How would you describe the texture of Play-Doh? I'm gonna look at my chat. The texture of Play-Doh, what does it feel like? Squishy, tough but moldable, soft, smooth, I love it. What would you say would be a difference between Play-Doh and then like a clay? Yeah, not as malleable. Clay is harder. There's a difference in the water content between my clay and my Play-Doh. If you've ever made Play-Doh, Play-Doh has a fair amount of salt in it. And so what we're challenging our students to do is think about those ingredients. And then in a moment, they're going to be thinking about the ingredients or the foods that they put inside their body. Okay, but I got a little bit ahead of myself. What you're going to have them do with their Play-Doh and play, after they've recorded all of their observations, Play-Doh smells, it's hard to explain, it smells like Play-Doh. But all of the observations you put, one is smoother than the other, one is malleable, one is squishier, whatever words make the most sense for your level of kiddo. Then they are going to make 2 pea-sized spheres out of each material and set them aside. Okay. So We know that our brain is kind of like Play-Doh. It's a little bit squishy, it's malleable, it changes over time. We can mold it and shape it into thinking things and imagining things and dreaming about things and being curious about things. But we also know that electricity is flowing through it, making the pictures that we see and making our thoughts. So using our clay as our model for the brain, we're going to want to add some electricity to it. In your kit, you'll receive several of these LEDs. And I know that you probably can't see the one in my hand, but you can probably see the one on the screens. You're going to notice that each LED has a long leg and a short leg. That's important because it's going to match up with your wires in this basic circuit. So pay attention to which one has the long leg and which one has the short leg. You could also add a little bit of fingernail polish to the top if you're trying to do it with kids, and you're going to pre-bend them depending on the age level. That way you can still recognize the length. Okay. You're going to bend the wires of that LED at 90-degree angles and insert it into your Play-Doh. Okay. You are then going to take the batteries and the battery holder provided in your kit and the way I remember which one goes with which is that the long leg runs. Okay, so if I went back to that slide, the long leg is going to match up with the red wire, red being alliterative, red, run. So you're going to want the long leg of your LED to match up with the red wire. Okay. And just like the picture on the screen, you'll put the red wire into the sphere with the long leg. You'll put the black wire into the sphere with a short leg. And if I were not trying to hold this up and it was flat on the ground, you would notice that my LED is lit, except for now when the wires fell out, okay? Then you're going to have them repeat the process with the polymer clay. The Play-Doh lights up, the polymer clay doesn't. And the reason is, again, if we think about our brains like a series of circuits, the polymer clay doesn't have the right amount of water, it doesn't have the right amount of salt, and it doesn't have all of the ingredients that our brain needs to process the electricity. So we use this both as a model of the brain and how the brain functions with the electric current running throughout and making something light up, light bulb moments. But we also use it as an example of why we eat the foods we eat and why you can't just eat sugar. If you just eat sugar, you have polymer clay. Your brain processes slowly, not because you are slower, but physiologically because you don't have the right ingredients for your brain to be processing at the same speed or rate. Okay. So that's the brain and a deep dive into why it's working the way it's working. Depending on your grade level, and we're going to watch this video and then we'll take a quick break, but thinking about the brain and really getting kids to ask the questions at the depth that you might want them. This video is done by a gentleman by the name of Paul Anderson. He's responsible for the wonderofscience.com, and he really frames what it means to be thinking about our body as a system. So we just did an activity about the brain, and we know that the brain is like controlling the body as a system, but this video will help either you or your kids to start to be thinking about how things interact intentionally. So here we go.
Hi, it's Mr. Anderson, and this is Thinking in Systems Level 1, Parts Working Together. As we think in systems, this whiteboard will always represent the system. We'll get to that in a second, but what is a system? A system, as the title implies, is simply parts working together, and you should always define the system before you investigate it. This object will represent systems, and so there's going to be a boundary to the system, and then there are going to be parts that are working together within the system. But if you're thinking in systems, you're not thinking about any one part, but how do all these parts work together? So I'll put this up here as a reminder to what a system is. After you watch this video, you should be able to do system thinking around something like a dry erase marker or a living system like a water lily. But I'm going to show you my thinking around a simple 4-gear machine. And so that will be our first system, and then you and I will do a different one when we're done. So the first thing you should do is define the system. So the system we're going to investigate is the 4-gear machine. Next thing you should do is play with the system and make sure you fully understand the system. So I think I understand how this works. What's great about this one is I can take it apart. So there are, let's see, 5 different parts to this system. There's the board, and then there's going to be the different gears, and then they're going to work together. So let me list all the parts of the system. So once you've defined all the parts of the system, you're halfway there. So now we have to figure out how do all those parts work together within the system. So this whiteboard represents the system. I would try to organize all the parts almost like they are in the 4-gear machine itself. So the board is kind of on the bottom, got the gray gear on the right side, and then it goes to the orange gear, the blue gear, and the yellow gear. So now that I've got them organized in the system, I want to show how all of these work together. So let's look at the gray gear. How does the gray gear work with the board? In other words, what's the relationship between the two? Well, the board holds the gray gear. It also holds the orange gear, yellow gear, and blue gear. So that's how they work together. The next thing we should do is figure out how does this machine really work? So when I move the gray gear, what that's doing is it's moving the orange gear. The orange gear, in turn, is moving the yellow gear, and it's moving the blue gear. So that's my thinking of the system. We could call this a system model. So I've got the gray gear, which moves, which in turn moves the orange gear, which moves the yellow and the blue gear. And I could test it. If I remove the orange gear, so on my model here, then the gray gear can't move the orange gear. And so when I move the gray gear, you can see that I'm not moving the blue gear or the yellow gear. So that's system thinking around a simple 4-gear machine. Let me move this out of the way. And what I'd like to have you do is do the same kind of thinking around another system. So the next system we're going to look at is this wooden car. Now we could look at the whole wooden car and how it works as a system, but there's a lot of parts, and a lot of the parts just are repeated over and over. So let's look at a specific part of the system. So that's going to be the part of the system that is surrounded by this blue tape. So that's going to be the part where we connect the wheel. So there's going to be a nut, there's going to be a wheel, there's going to be a bolt, and then there's going to be a block. And so what I'd like to have you do is create a system model for the following system. Let me define the system.
Okay, I'm not going to make you do the whole system of the car, but I found his videos very helpful because typically when I taught systems, I only thought about ecosystems, solar systems, maybe body systems. But when we...
So the system is going to be this one... Hi, it's Mr. Anderson, and this is Thinking in Systems Level.
Hold on. Okay. When we get kiddos thinking about the inputs and outputs of their bodies, what we're putting in and what we're getting out, it also helps them to frame, again, that function of the brain. I'm putting healthy food in, allowing my brain to work more effectively to transmit the electric signals. And then what am I getting out of it? Thoughts and energy and all of these other things. You'll notice that in the student guide that it kind of scaffolds in the light bulb brain. Investigation helping us to examine how the foods and drinks we consume may impact our body's functions. What do we notice about the two substances? What happened when we connected the two substances as a circuit? And what do you think that this means about the way our brain functions? So this would be the scaffolding that kids, again, could cut out and put in notebooks. You could have on different stations if you're setting this up in a lunchroom, having them talk about each of these sets of information. But really, and you could also do it as a demonstration just like I did, but really having them think about why the electricity may or may not be flowing and that idea around the brain. The next organ that we're gonna go to is the mouth. What I want you to think about and add into the chat is thinking about the produce on the screen, the celery, the apple, or the pickle. Which one would make you salivate the most? Which one is going to make your mouth water? I'm seeing lots of people pick pickle and some pick apple. Not a single person is picking celery. I'll tell you, this is a great opportunity if you're going to do this activity to partner with one of our farm to school, farm to table programs and have them bring in some fresh Kansas produce. So thinking about these three ingredients, foods, your brain is most likely to have you salivate when you smell pickle. I don't even like pickles. I'm just not a pickle person and I'm not a celery person, but it's okay because I'm not going to yuck on your yum. I'm sure that they are great for other people, but I'm with some of you who picked apple. Like the apple is the one that I would want to eat most. But our brain responds differently to different smells, different textures, and different tastes. So before you even take a bite out of a crunchy pickle, your brain is telling you, that smells tart. That's something I'm going to want to eat, which also makes sense if we think about, again, the function of the brain, wanting those salts and those liquids. Pickles are going to have the highest salinity and the most moisture content. So our brain knows that that's the one we should want to eat. Have kids take small samples, pass them around, have them smell it, and then give them that idea in their head of pay attention to what's happening in your mouth, not in your brain. What is happening to your mouth when you smell each of the individual items. Quick, easy. You could do it while kids are waiting in the lunch line. Now, after the lunch line, let's think about, in the video, they called it Mr. Gross Mouth. So in the video, they had the giant tooth and the giant toothbrush, and they're telling you to brush all of the sides and use, not rope, but floss to get in between. And friends, no matter how many times you tell a middle schooler to brush their teeth, there will always be that one that's like, I'm not going to do it, because they don't understand the why. So two ways to kind of frame this, tying in, again, the body part and the impact on it. On the screen, the lab was to take eggs and coat them in toothpaste and then submerge them in coffee and Coca-Cola. So that is one way that you can do it. And it would help kids to understand how fluoride continues to protect that enamel long after they actually brush. Like, it has that continuing protection that it offers. It's awesome. The other option would be to set up eggs again. And the reason that we're using Kansas eggs is because of that outer coating on top of the membrane of the egg that acts as, again, protection, but it also functions the same way our teeth enamel does. It's soft, it can be dissolved by sugars and acids. So it's a really nice model, representation, correlation between what happens on our teeth and what happens on an eggshell. So on the student guide, you'll notice that I allowed it to be set up in a different format depending on how you want to do it. For me, I have 4 plastic cups. One is just a everyday egg in a cup. One is milk. One is Diet Dr. Pepper because that's what I had at my house. And one is orange juice, thinking that many of you probably have a juice option in your cafeterias. Okay. Last night I took the eggs, I submerged them in the cups just to get a start to feel what was happening. In my milk cup, no change. I'd highly recommend washing your scoop in between. In my Diet Dr. Pepper cup, there are 2 things, and I don't know if you're going to be able to see it or not, but my egg is actually cracked on the exterior, and it looks very similar to that egg in Coca-Cola. It's starting to dissolve, and it's definitely brown. Now I'm going to set this one to the side just for a moment. My orange juice one. The most interesting thing about the orange juice egg is that you'll notice all of the bubbles on the surface. Part of those bubbles is from the acidity of the orange juice reacting with the shell of the egg. Okay. We will be providing the cups in your kits, but unfortunately thought that it would be better for you to partner with a local egg provider instead of us trying to ship you eggs. But we did partner with Delta Dental, the provider of most Kansas education dental insurance, and they provided us toothbrushes. So we'll be sending you the toothbrush and the toothpaste. And what you could do would be to have students observe what happens to the egg if you brush it. Okay. And again, I know that you can't see very much, which is why there are the pictures on the screen. But even scrubbing this Diet Dr. Pepper egg that's only been in there for about 12 hours, it's not all coming off. It is into the shell of the egg. It has stained the eggshell. I would highly recommend that you set this up as an experiment where in the cups of eggs and the toothbrushing, you have one where they never brush it, one where they brush it every other day, and one where they brush it every single day. Have them make observations and record what's changing. To give you a preview, the orange juice will dissolve the outer shell, but it won't stain it. So it'll just slowly deteriorate with the sugars inside the orange juice and the acidity of the orange juice. The Diet Dr. Pepper will stain, dissolve, and deteriorate the shell. The milk will also slowly eat away at the eggshell, but not anywhere near what the orange juice or the cola is doing, and it won't discolor at all. And I love that analogy because so often we'll think, oh, well, I don't drink soda, so I don't need to brush my teeth. No, the sugars and the lactose inside of milk still have the impact on decay. So, yeah, in addition to that, if you're teaching a higher grade, have them pay attention to the smell. Oftentimes, kids will know that they have stinky breath, or they'll know that somebody else has stinky breath, but they won't make the connection in why. Where is that smell coming from? Once you realize that it's the souring of the food and the waste of the bacteria that's crawling on their teeth, suddenly you start to see them take more of an interest and increasing those teeth and gum habits. As I mentioned, the Better Brush activity, I left it fairly open, providing just boxes and columns so that depending on your space, obviously if you are in a gymnasium, you might not want to have eggs sitting there for like weeks on end. So you might want to do it as a demo, have them out as like a station where kids are observing the differences in what happened to the shells, but leaving that open-ended so that you can tailor it to your space. Now, we've walked through the brain, we've walked through the mouth. It's a great time to step back and have kids revisit those questions. So let's see how well we're doing on the questions that you asked. I'm going to go all the way back up to what we called our driving question board. And back over to the student questions. Which one or ones have we kind of answered? And I am seeing a question in the chat about kept refrigerated or no. It all depends on your level of tolerance for stink. The milk is going to stink. I, as kind of the science person, love that it smells bad because, again, it goes along with that idea of like why our breath smells bad. But if the stink gets to you, by all means, put it in the refrigerator. It will change the rate of decay. So when things are hot, they speed up. So if the milk is hot and the orange juice is hot and cola is hot, it'll speed up that reaction and go a little bit faster. But it's completely up to you. Which questions on our driving question board have we answered? Did we answer any with the brain? Thinking back to those two different substances. Did those two substances perform the same way, the clay and the Play-Doh? I'm going to say no. And so if I think about this, is everybody's inside the exact same? Now, I think we could claim that depending on what we eat or drink, our insides, while we have all the same parts, what we put in, again, thinking about that systems models, inputs, outputs, what we put in is going to determine how we look and how we function. Also in the video, thinking about the model of the muscle versus the fat. So if I were with students, we could definitely say that we've answered part of this block. And this one, we've answered why we can brush our teeth, but obviously you would want to talk to them specifically about what your school policy is with tooth and teeth brushing after lunch. Okay. Brain, mouth, questions? Okay. Here, thinking about the structures and what we've learned about the mouth, what do we think the structure of the mouth is? And the reason I threw this question in is, again, thinking back to our produce and getting the idea about salivating. Oftentimes, kids will know the function of the mouth is to chew the food, but we really want them to start to think about why, because there were a lot of questions about the intestines. And the next one is the stomach. So your stomach is growling. Why? Why does my stomach growl? It's easy to think, well, my stomach is growling because I'm hungry, But sometimes I think I'm hungry and my stomach doesn't growl. So why does it growl? How does it growl? What is all this growling about? In thinking about the sounds that our body produces, it's important for kids to recognize that sound, all sound, is coming from vibration. So for this activity, have kids not only put a fruit or vegetable in a baggie and seal it, add your favorite type of acid, whether that's orange juice or cola. I would recommend vinegar because it's clear, and seal it. Have them observe what happens inside that baggie if you just let it sit. Then have them observe what happens to that baggie when you mash it. Okay? The function of the stomach is obviously to break down food, but it's the combination of the chemical reactions inside the stomach and the vibrations. So getting kids to recognize that the stomach also operates kind of like that blender of meshing and molding and massaging food into the smallest substance it possibly can is really critical in understanding what's going to happen next in that intestines we seem so excited about. Okay, now I am really excited about this activity, but I also understand that it may be a little gross, but it also really talks to the heart of what the intestines does, and it gets kids up and moving, which is what's happening to the food particles inside the intestines. So this would be an activity that you would definitely want to do in your physical education space or outside. And it is the equivalent of sharks and minnows, but it's intestines tag. Are you still with me? Because I know that sounds gross. I really tried to come up with another name, but I also think that kids will enjoy it because it's kind of funny. The biggest misconception I see existing in our classrooms about the function of the intestines is that it's a filter. So a lot of times, if you've seen these activities before, people will take a long strand of pantyhose and like squish it through the pantyhose to show that the food's coming out. The problem and the limitation with that model is that it really solidifies the fact that it's a filter, which we really don't want them to think about it like that. We really want them to think about the intestines as that point of absorption, transferring from the digestive system into the bloodstream, which is weird for them. So to help them get a visual on it, we've taken a twist on a very, very common game that's done in PE classes called Sharks and Minnows. In this game, the minnows are the food particles. So they're the piece that's moving. The sharks are the villi that are stationary but tagging the minnows as they run across. And the intestines are really that room or hallway wherever you choose to play. Now, in round one, you have your intestines, which is your room, without any villi, and the food is only the food touching the wall will get absorbed. Okay, now, again, just to refresh, the minnows are the food, the sharks are the villi, and the intestines are the walls. So in round one, if you don't have any villi and all you have is food running through the space, what's going to happen? Looking in the chat, I'll tell you that all that food is just going to run right through, right? It's not going to get absorbed. It's just going to pass through the intestines. In round two, you have the villi spread out throughout the intestines, and they're stationary. So they're just there, but they're touching any food particle that comes into contact nearby them, okay? And they're absorbing that food. In round three, the entire intestines, the walls, the floor, everything is villi, but your minnows have a ball or some other substance that they can roll through, and that's the fiber. Okay, So fiber gets passed through the intestines. It's the part that can't be absorbed because you can't like take in the ball, but the food gets absorbed. Again, this activity is a little bit of a stretch, but we really want them to get an idea and think through what's going to happen in this situation as the food is moving through the body, and the role, again, of that villi to really make sure that the food particles are picked up, not like a sponge, but absorbing it, not like a filter. So intentionally tying together what happened to our bodies. So I'll ask you again in the chat, what's going to happen to the kids that are our poor food particles and are running back and forth across the gym? What do you think? Friends, I taught middle school, I can tell you, but I want to give you this opportunity. They're going to get tired and they are going to be hot and smelly. Another opportunity to talk about bacteria, but also, why are they hot? So asking kids that, what happened to your body as we played? Why did you get hot? Is going to take us into this idea of blood. Now work with me here, because I know that that seems kind of like, what? Blood? I don't think about it. So why did we get hot and sweaty? Why did we get tired? Why did we sweat? Why did we perspirate? Like, how did all that happen? We want to introduce the concept of the blood being something that carries nutrients and water and all of our ingredients throughout our body. So what I have is another model, another physical model. And it will be included in your kits. And what I have are water beads. And I know, I'm gonna like try to come up to the camera. You probably don't have this in focus, but these are less than a millimeter in diameter. They're teeny tiny. And the way a water bead works is you submerge them in water, and then they absorb the water, and then they grow, okay? Depending on where they are in the container that you put them, they can get as large as a marble, or I'm trying to find a small one to compare it to. Some places in the container, they're still teeny tiny, and some places they're really big. I love the idea of water beads, just like I love the idea of really having them get away from this idea that the intestines is like a filter. I want them to understand that blood cells absorb liquid and can also, we have osmosis and reverse osmosis, right? Like things are coming into our cells and leaving our cells. So I want them to not think about them like a giant baggie. I want them to think about the cells, our blood, as this transform agent that's absorbing and releasing as it goes throughout. Same thing with the water beads. It's absorbing the water, but if I leave them sitting out, they shrink back down. So the idea that they're only what they are when they have the substance in it. I made the tub full so that you could get a visual on what 3 tablespoons of water beads looks like. So don't be sad when your kit doesn't have a ton. Put them in the water and they will get massive. If you want to expend on it, and I should also add, water beads are the common ingredient in sensory tables. So a lot of times you'll see them in like kindergarten and preschool classrooms as kids just play with them. They have a great texture. You can add other materials to your water bead tub to simulate other pieces. The more water you add, the more they'll kind of float before they grow. And so it looks like your plasma, in addition to having your red blood cells. You can add ping pong balls, which don't really represent the function, but definitely give you a scale, proportion, and quantity glimpse. And then the platelets, If you think about like grouping those together as you move your hands through the water bead tub, can give you an idea of how they would help clot. Okay, but really the whole goal with the blood piece is understanding it as a transport agent. Okay, so in your guide, in the teacher guide, you'll notice that it's going to have them draw this model twice. The first time, they're just drawing their initial ideas. So the question is, what is the function of our blood? Thinking about the water bead as an example and using the square below, make a model of how and where you think the blood absorbs nutrients in our bodies. Okay, and they're just going to draw a picture of what they think is happening. Originally, I was going to have us do that, and I still can. Otherwise, I'll show you what comes next. Oh my goodness. In the chat, she knew exactly what was coming next, or they knew exactly what's coming next, okay? So we've done our sharks and minnows game, we played intestines tag, we've looked at the blood, which is really leading us up to this idea of the function again, and how does it move and why does it move? Tying together 3 body systems, inputs, outputs, and the way they relate to each other. In your kits, you're going to have a pulse oximeter. Kids will likely already be familiar with this tool because it is a very, very common thing that they experience when they go to the doctor's office. But oftentimes we don't see that they pause and ask the doctor, what, why? Again, it's a place with a lot of science that we don't feel safe asking questions sometimes, and we want to encourage that. So with the pulse oximeter, all you do is you turn it on and you insert your finger. And then it will put out 2 different numbers. Even if students don't have any familiarity with what those numbers mean, that's okay. Again, because it's a place for them to make observations and then ask questions. So on the screen, you'll see that it says, run or jump in place for 2 minutes, take a beginning reading, take a final reading. You could also implement this when they're playing the game, even though they don't really know why yet. What happens to the oxygen level? What happens to the heartbeat? And how might that matter with our blood? Okay. Thinking back to systems, what we want them to notice is that the oxygen level hopefully is staying the same, even though their pulse rate is increasing. What that should tell them is that even though we're taking in approximately the same amount of oxygen, our bodies are having to move faster, increasing our pulse rate to move it all the way around our body so that we can move our bodies. It's pretty cool when you stop and think about it. And then what are they carrying? Like, why is our blood increasing? Our pulse, our breathing feels like it's increasing. It goes back to this idea, tying it in to it's moving our blood around, which is moving our oxygen around, because our oxygen is delivering those pieces to the rest of our body. Okay. Questions about any of those 3? And yeah, you can definitely do one before and after. And they will be tired, so do it in the afternoon or after they've had a good meal so that they get some more energy. I'll take questions or comments. If you have an idea on how to improve this, I'd love to hear that as well. One of the things I love about having them going back and revising this model after their exposure to the pulse oximeter is that they will have been able to show their learning. Sometimes kids are like, oh my gosh, we did that and it was so much fun, and then they forget what they actually learned about. This way, they are drawing those connections and tying it together. Now, as I said before, I would target this particular activity 4th grade and up. Your itty bitties probably aren't going to be able to draw these conclusions on their own, but it is a great time to supplement with a text. So whether that means you're showing a video, that you maybe have through one of your supplementary resources, whether that means we watch a lot of Magic School Bus at my house. Regardless, this is a nice time to have them engage in really revising their model, both on the data that they collected and on some sort of exposure to a text. And you'll notice in the guide that there are a couple suggestions on where those text readings could go to help build up their understandings. In the chat, I see, I like the fact that the stronger your heart is, the fewer beats it takes to pump the same amount of blood. Yeah, you'll notice that I did not show you my heart rate on the pulse oximeter, but it's cool when kids can see that too and think about why, because they will ask that question, they will compare. And so it's important to really be sensitive of that and maybe prep them before that. But yeah, the stronger your heart is, the less hard it has to work. I love that. So this does not relate to the last three. It's kind of the downside to working through all the systems. Some of them have this beautiful integrated connection. This one, it's still dealing with that movement, but it's not as beautifully intertwined. So remember, it's a choose your own adventure. If you want to do just one of these, if you want to do them together, whatever works best for you in your space. I also included a video because I felt like at this point, a song, getting them moving when we're talking about movement, because we're talking about muscles and bones next, might help. So this one is another kind of differentiating downwards with this idea of Jack Hartman brain breaks. But what I love about it is I could have played this entire song and it goes over and over and over again. I move my, kids are probably dancing along, we're getting wiggles out, we're incorporating movement again. But at the end, after moving our toes, my question as the teacher is, how? Because we just did, I move my, and it's this idea of how. It will feel so strange to your students to do this, but for a moment, like probably an entire minute, and I would set a timer, have them observe their hand. So many things we take for granted in this life, but seriously, have them stare at their hand. Maybe have them draw a model of it, maybe have them collect some data on it, but really what I would want them to see is thinking about I move my, and thinking about how this moves and where it moves. Ultimately, and I kind of gave the answer away because it's on the screen, ultimately, I'm wanting them to understand that our hands or our bodies are made up of bones and that those bones work together to move my hand, foot, head, etc. Okay? But that they don't move independently. There's a relationship between the muscles and the bones that allow this to occur. You can scaffold this as much as you want, but ultimately I would want my students to count the number of intersections of their hand, count the number of bones, and then build a model to represent how the bones and the skin, and in this case, the muscles, work together, okay? Depending on the grade level, they could label it. Again, depending on the grade level, scaffolding it. But understanding that the skin is the coating, that the bones are important for where we see our connections being able to intersect and provide structure for how it moves. Okay. You'll notice that in the muscles and bones, we didn't really spend a lot of time talking about ingredients. The fact that you need the calcium in order to build the structure, the fact that blood is created in the marrow. We didn't really go that deeply because for this unit, I felt like it was really focusing on structures and functions. So what are the structures in the hand? What is the function of the hand? And how do the structures work together to accomplish that task? Lots and lots of different ways that you could provide variations and scaffolding on this activity. And See, again, some of them tie together really beautifully and others don't. This activity, I used construction paper because I felt like it would be easy for kiddos to trace. This is a very common activity you can find on the internet. Depending on how you want to scaffold it, you could change out the material to plastic wrap. So if I were to pick 3 organs that kiddos typically have misconceptions about, 1 would be the intestines, 2 would be this idea of cells being little baggies of water or just baggies in general, and 3 would be the skin. Start by having that conversation of like, what happens? Like, what are all the things we do with our skin? And then have them think about what's actually happening. Again, it's like the hand. If we don't take the time to think about it, we skip right over it. Our skin is so cool because I put on lotion on my face at night. And the lotion bottle tells me that it makes me look 25 years younger. I'm not so sure about that, but it's a scientific claim that lots of companies are making. So how would that work? What happens when we're in PE and recess? We already addressed that we are stinky hot messes. So thinking about the fact that our skin is letting some things in and some things out, it gets the idea of the skin, again, depending on your grade level, being this selectively permeable membrane. Some things in, some things out. Take vanilla or any essential oil, put a drop in the bottom, cover it with plastic wrap, and it can be a cup, it can be a tub, it can be whatever you want. It can be a spray bottle, and just have them smell the outside. You can still smell it. So the fact that even some things that are happening inside of our skin, our pores, allow us to let things in and out. Simple concept, but also really, really, really important when we think of what kind of environment we're in. Thinking back to the black lungs that were shown in the video, what does it mean if we're around pollution, environmental toxins, things of that nature? Really being mindful of all of the environmental factors that impact our skin. I live near the Speedway, and so this is something I think about a lot. Just like every time they have one of those massive races and you can smell the tires in the air, it's like if I can smell it and it's entering my body through my nose, how else might that be impacting my hair, my skin, and all of those other components? It's not a fun thing to think about, but it's a really important thing to think about as we're taking care of our body inside and out. And with that, the last piece would be your choice if you choose to do an assessment. If I were to go back and show you those standards, you'll notice that the #1 standard, both in the 4th grade and the kindergarten part piece for the science, is to form an argument. So what does that look like? Because how do we argue about our body? Really what we're asking them to do is make a claim, support it with evidence, and provide some reasoning. Now they could do this in a scientific paper, or we can tap into that other side of our brain using that idea of neuroplasticity and write a creative story about it. Personify some of our pieces. Have students pretend like they are a food particle that has walked through our body and explain the journey, really making sure that they're connecting all of those pieces together. And even though it's a fictional story, citing that evidence, I think in the teacher guide, I suggested at least 3 pieces of evidence for each system that they encounter. Again, the pieces that we've left out are really talking explicitly about when to incorporate readings. I find that our libraries are full of high quality books about the human body. So I didn't take the time today to have you read those. There are tons, I guarantee you. So encouraging them to supplement and investigate where they're interested in, and then using something creative to really assess their understanding of science. It's okay to incorporate creativity because ultimately that's how we drive innovation. How does our body work? How do we want it to work? Yeah, it's kind of cool. New exercise systems come out every day and other ways to keep us healthy. Okay. That is the unit in its entirety. The kits. So included in your Body Venture kit will be a student activity book for each kiddo. Now, these are different than the workbooks that I'm going to send you electronically. These student activity books are brought to you by Child Nutrition and Wellness, and they are a great way to incorporate your community. So the way I would envision this, and it makes my heart so happy to think about, is you giving one of these to each kid, having them go home and complete them with their family members. You'll notice that inside is the My Plate, and then breaking down the foods. You'll also notice that it is supposed to be fun. So there are word searches, there are connect the dots, drawing a big smile on your face. Make sure to put lots of teeth in there. All sorts of different, just fun things for them to go home and talk with their family members about how to stay healthy and how to take care of their bodies. Also, sharing some of those facts about all of the body parts and systems we've learned about. Okay, so when you fill out your form in just a minute, you'll see the opportunity to put in a number for these books. We have tons of them. So as many kiddos as you see or envision using this unit with, feel free to request that number of books. Also in the kit will be the equipment and the materials to do the investigations we saw today for the non-perishable labs. And what I mean by that is I'm going to send you the toothbrush and the toothpaste, but I can't send you the eggs. We hope that you'll partner with your local community farmers and be able to source those independently, and apologize for not being able to ship them. It would delay shipping time. Hopefully you understand. I think you do. Pulse oximeters, muscles and bones kits, heart materials. I do want to mention on this activity, we are sending you straws, but are intentionally sourcing compostable ones. I know that has been an environmental issue. So I would also encourage you to have that conversation with kiddos about reduce, reuse, and recycle as well. And the heart materials with the water beads, again, be mindful that a little teeny tiny bit goes a very long way. After we get off today, I will also be sending you a digital and editable copy of the teacher guide and student workbook. And if at any point you have questions, concerns, feel free to reach out to me because we can modify those at any time. Last but not least, thank you again. I started with the thank you and I want to end with it too. The fact that you are here doing this training, wanting to engage kiddos in both science, physical education, health, and just exploring their world is huge. So thank you for the time that you've put in and will continue to put in. Also, this is 100% partnership between the Career Standards and Assessment, and all the materials are being provided from Child Nutrition and Wellness. Feel free to reach out to either of us if you have any questions, or if there's another way that we can support you in thinking about how to incorporate standards into great practice I'm sure you're already doing.